Screen is visible. Domestic installation and home appliances. Okay, right. Yes, today we'll see some of the aspects regarding domestic installations. So maybe we are trying to look at a problem not to understand a typical low voltage 3-phase 4-wire single phase AC supply for residential building. Look at the words. Now we are discussing about residential and commercial electrical installations around us. Commercial means commercial complexes. Residential means house connections, home connections, electricity. So wherein we require, we will be dealing with low voltage. Low voltage is generally 440 volts. 3-phase, of course 3-phase is required. Then 4-wire. Why there are 4 wires? 4 wires are because of 3 phases and 1 neutral. And single phase. From this 3-phase, I can take any one of the phase and use 1 neutral so that it becomes a single phase AC supply. So this is the arrangement. Let us look at the further details. Single phase supply is commonly used for domestic supply and small commercial also. Commercial complexes, commercial shops, etc. Generally, the loads are around 1.5 kg. This is the old data, 1.5 kg is the old data, but presently we can go up to 3 kilowatt. Why 3 kilowatt? Why 3 kilowatt means at least 1 kilowatt is for 1 kilowatt is for our iron box. All our present day iron boxes are of 1 kilowatt. Therefore, there is a yes. So single phase supply is commonly used for domestic applications. I was talking about 3 kilowatt. How this 3 kilowatt is? 1 kilowatt is for electric iron. Another 1.5 kilowatt is for geysers, electric heaters, water heaters. And another 0.5 kilowatt is for washing machines and other equipments. This is the typical household uh, across India we can see. Open it. Open it. चाबी अलग ड्रा रहेगा. one ड्रा हो. So, supply wires of single phase AC supply consists of one phase and one neutral. You may be wondering, why are we discussing such silly information in the fine layer. Are you feeling like that? Some of you might be feeling, why we know all these things when we were in our first year, but why are we discussing such small things in final year? Lingaraj? Yes or no? Vijay Lakshmi? Vijay Lakshmi? Hazra?
Yes, sir.
Yes sir means
Yes, yes. We have studied in first year, sir.
correct. Then what is the point we are looking at these things in the final year? Pramod? Because that is very important. Why are we studying this in final year? That's very important. Right. Now, as we discussed, single phase AC supply system consists one phase and one neutral, and that neutral is generally earthed at transformer neutral at supply end and one bare earth wire that we can see here. For a total connected load of 2 kilowatt and above, three phase 4 wire low voltage supply is recommended. Three number of phases and one neutral wire. This is the arrangement. So industrial single phase loads are connected between phase and neutral via switches. Protective earth wire is provided in the installation. This wire is connected to building earth. Okay, that's a different thing. Now you can see phase 1, phase 2, phase 3. Line 1, line 2, line 3. This is a three phase supply. And between each phase we have 415 volts, which is called low voltage. This is a three phase supply. When I take one phase and one neutral, look at this. I'm taking one phase and one neutral. What I get is through 230 volts. So this is called a single phase supply. Single phase. So I'm taking one line and one neutral. This is single phase supply. Likewise, what is generally done is, if a three phase line is available, generally we try to distribute the load between all three phases, possibly equally. So that is how the load is distributed. And we know that this supply lines or the phases, they are generally aluminum conductors, ACSR. If you raise your head and look at the wires running between two poles, they are the, if there are only three wires, then you can call it as a three phase supply is being carried. And if there are four wires, if you see, then it is three phases and one neutral. That's the way. So whenever you come out of the house and while going on the street, just look at the wires and you'll make yourself what is what. Then mains connected terminal board. Three-phase wiring has three-phase wires and one neutral wire plus one earth wire. So these are the terminals available in the board. In case of single phase, one phase wire, one neutral wire, and one earth wire. There is a difference between a neutral and earth. Earth wire is connected to residential protective earth plate. Yes, there is something called as earthing. Earthing is done for every electrical installation, and this earth wire is connected to that. And the main terminal board of the consumer premises, maybe it is our own house, will consist main switch fuse unit with MCB, then energy meter, then earth wire, then sub-circuits if any. Maybe small residential houses will not have sub-circuits. Otherwise, if it is an apartment or other things, then we have sub-circuit MCBs also. So that I can only operate the particular MCB so that power can be cut for that particular flat number, for that particular house in a residential complex. So this is how the arrangement is there. This is a three-phase supply generator. Then we have power, one neutral and earth wire. This is a terminal box from where it goes to energy meter, and from energy meter we have the switches, maybe ironclad switches making on and off. Then we have fuses. Then again we have sub switches connecting to each individual load. And earth wire is running from generator through each individual meter board. From the company side means supplier side. In this case, the supplier is the electricity board. Now, from where we take the supply is from the transformer we take the supply, and until transformer, the distribution company is able to connect the electricity. So therefore, from supply company side, we have a distribution transformer, generally star connected on the secondary side, star on the secondary side, primary on the delta side. Why star? Because I want a neutral point so that I'll get single phase supply also. Therefore, this system becomes 3 plus 1, 3 phase but 4 wire system. Then fuse cutout on service side pole, supplier's fuse. This generally we will not be able to see very easily, but if you keenly observe the transformer substation nearby your house, you can see these things also. There is some fuse arrangement, but definitely not properly maintained. That is a sad part of it. But you can certainly see transformer along with some fuses. Maybe in India, most of the fuses are bypassed. Therefore, this fuse never works. So if there is any overload current or any faulty operations of electrical equipment, directly it is transferred to consumer side, and consumer is at loss. Then serviceable cables, 3 phase 4 wire between the company and the consumer. So this is what is the connection between the company and the consumer. And on the consumer side, we can see junction box, same thing. House, terminal board in house, serial number 5, this is the terminal board. Serial number 6, 3 phase energy meter, 6. then 7 MCBs, 8 fuses, 9 phase wires, 10 neutral wire, 11 earth wire, 12 again the fuses, secondary fuses, then 13 residential earth point, then 14 supply earth point. All these things we have as a connection terminal board in a typical residential building. Maybe this is true even for the commercial building. And see this energy meters, generally kilowatt hour meters, they are called kilowatt hour energy meters. Kilowatt hour. They are the kind of recording instruments. There are three types of instruments, measuring instruments. An energy meter is a part of recording instruments. It continuously keeps the record of it. Integrating meter it is. It goes on adding daily readings. This device is suitably positioned so that the meter reader can read without access to the house. This also you might have observed. Earlier, the meters were used to be inside the house. Inside the house. Recently, government has taken a step to keep the meters on the outside wall of the house. I think many of you might have observed this. That is only so that the meter reader can read without access to the house. Without entering the house, he can read the meter consumption so that he can issue the bill. Most of the time, what was happening, houses were used to be locked and meter reader was unable to issue the bills. So that was the reason why meters are taken out from the house. MCBs, linear circuit breakers, are preferred due to their accurate characteristics. No need for replacement after tripping. These MCBs have become nowadays very popular in place of fuses. Generally, what happens to the fuse is, if there is an overload, fuse wire burns. Then we need to replace it after removing the fault. Whereas MCB, that doesn't happen. It directly trips and circuit is disconnected. And once the repairing is done, fault is removed, just we can make the circuit on by pushing the button up. So that's why, and they're very accurate. If you set it for 5 amps, certainly it operates if the current is flowing beyond 5 amps. Because of their accurate characteristics, MCBs have become very popular in domestic installations, in commercial installations. These are the general terms. Current coil is, you know it. How an energy meter, what is an energy meter? You know that current coil is in series with the load and voltage coil is across the load. Because there are two coils, current coil and voltage coil, it is able to measure the power. V and I. V into I is the power. Therefore, energy meter measures power continuously being utilized and it records how much power is utilized every second and added together for an hour. It is measured in terms of kilowatt hour. It is also called 1 unit of electricity. In common man's terminology, kilowatt hour is called as 1 unit. 1 unit. Yes. Then we have lighting loads. Look at the circuits. This lighting circuit is generally required for definitely for domestic premises, but also for commercial buildings, public places, shops, and factories. This is the lighting load. We are not talking about industrial load. It's a low voltage we are talking. Here, generally what happens, we take a line and neutral, and can you see the connection? So this is how the lighting load is connected. Every lamp has individual switch. You can make it on and off. Look at the circuit. If I make this on, current will start flowing like this. Through this, the bulb is on and completed through neutral wire. I can put it off. Yes, current is flowing in this way. It cannot flow because the switch is off. In a similar way, I can operate this. You can see this is open, no current flows. Now this is closed, current is flowing, because of which we can see second light is on and there is a current path like this and completes its path through neutral. So this is how the lighting load is done. This is very important. Lights, all the bulbs are connected in parallel along with individual switches, and this is a typical connection. Then also we have a radial connection. Radial connection. Can you see this? Radial connection. There is a slight difference between ring circuit and radial connection. This is called radial and the ring circuit. We have a ring of phase wire, phase, and similarly a ring of neutral wire. That means at every part of the residential building or the industry factory, we have two wires running, phase and neutral. At any point we want, we can just tap these two wires and have the load connected, have the lamps connected. It's very easy now. Everywhere we observe two wires, just take out two taps and connect the load. And also we can insert certain sectionalizer or load breaks. The advantage of this is only by doing this, what is happening? See, there is a phase and neutral here. What will happen? This circuit is completed. So this is available on, this is also on, this is also on, but current is not flowing between this and this. That means now we have made from one ring, we have made two sections. This is one section, this is another section. This is also possible by putting some certain load breaking switches or isolators in the ring type connections. For making the light on or off, bulb on or off, we use SW, single way switch. Sometimes they are also called as single pole switch, SP switch, single pole or single way. It's only single way. Either it is on or it is off. And sometimes we also have a similar switches which are called two-way. Two-way means they have one connectivity or they have another connectivity. Generally, these two-way switches are used for staircase wiring, staircase wiring. This already you know. Then we have master control switch. Master control switch. Let's see what is that. This is the master control switch. Master control switch is near to the energy meter, we can say. So if I make it off, everything will go away, go off. So in case of maintenance, repair and other things, I use the master switch. Or there are other applications of it. If I put the master switch on, all the bulbs are automatically on. That is also possible. In that way, the master switch is utilized. Anyway, this is not into your syllabus. We are not going to discuss. Describe the construction of a kitchen hot plate and connection of. But this is very much required for describe the principle of microwave oven. How this microwave oven works. Principle of operation. Microwave oven. It is a box. Because of frequency, we get the food heated up. Hot food we get because of the frequency. Microwave oven. Yes. Next we'll see elevators. This is one of the important factor. Describe the configuration and working of an elevator. Elevators, in our general terms, we call them as lifts. Lift carry us from one floor to another floor. So this is a typical schematic diagram for elevators. This is one alternative. This is the second alternative. Most of the time we see this. Most of the time we see this type of thing. This is called 1-to-1 rope drive. This is 2-to-1 rope gear elevator. And this is most popular. So how it's operating? Just you can see. There is a counterweight, and there is a carriage. So this is where the people stand for moving from one floor to another floor. Because of this counterweight, there will be ease of movement of the car. When this is going up, what will happen? Car will come down. And if you want to go up, the counterweight has to come down. That is possible by turning the motor in one direction or another direction. Are you getting this? If you want to go up, the counterweight has to come down. Counterweight has to come down. Why there is a counterweight? It reduces the load on the motor. Because of natural weight, it reduces the load on the motor. So now the motor will start rotating in this way, which is anti-clockwise. So if the motor is running anti-clockwise, the car will move up. And to make the car down, what we do is we make the motor to run in the clockwise direction. So when it is moving in the clockwise direction, can you see? This counterweight will go up, therefore car will come down. So this is the arrangement of elevator system. Similarly, there is a second type of elevator, and these are the parts of the elevators. You can see, first one is a car, hoisting rope, it is called hoisting rope. This one, hoisting ropes. Traction sheave, this is traction sheave. This one, traction sheave. Secondary sheave, fourth one. This is the secondary sheave, which will make the rope to move smoothly. Then fifth one is ideal sheave. This is ideal sheave. Sixth one, compensating sheave. Compensating sheaves. This is compensating sheave. Seven, counterweight. Compensating frame. This one is a compensating frame. Then compensating ropes and chains. Ninth, this one is a compensating chain or rope. See, look at the names. Above the car, whatever rope is there, that is called hoisting rope. It is on the head of the rope, hoisting rope. And what is below the car? Below the car is called compensating rope or compensating chain. So different names to identify what place is where. A gearless DC shunt motors are with grooved driving sheave and brake pulley directly mounted on the armature shaft. This is the motor generally used. Most of the time they use AC induction motor or a DC shunt motor. But in present day technology, we can see AC induction motors are being used. DC shunt motor is a very good if you want a smooth control, but operation is getting them and into operation is difficult. Therefore, AC induction motors can do it. So this is all about elevators. Elevator motors. Special requirements of elevator motors are utmost safety and reliability. Safety and reliability. Safety. The motor has to operate and reliable, and for n number of operations it should give its performance. Otherwise, think you are in the lift and motor doesn't start. What is the condition in between? Therefore, safety and reliability is prime importance of for elevator motors. And automatic handling or negative or overhauling loads. That means on one side it may be traveling without load. If you are on that 7th floor and you are calling the elevator, so elevator may be traveling without load, and along with you in the 7th floor, the capacity of the lift is 5 people, but there are 7 people standing in the cabin, standing in the car. So that also it should be able to handle. Or it should be able to give a signal that weight is more, so somebody can go away from the lift, go away from the elevators. So ability to stand up and perform well under repeated starting and stopping, because elevator, imagine in a commercial complex, so many people will be keep coming, keep utilizing it. So it should operate properly. Repeated starting and stopping, it has to withstand. Generally, a busy elevator may make up to 200 stops per hour. So 200 operations per hour, it has to withstand. So this is the typical characteristics of an elevator. Quietness and freedom from vibration. Even after that, even after this 200 stops and starts per hour, the motor should be able to operate quietly without making any noise and without making any vibrations. So that kind of quality is required for elevator motors. Yes. Next, let us look at sketch an electrical distribution system in a high-rise building. High-rise building means complexes. High-rise buildings. How the electrical distribution system will be there. I think these things will take up in our next class. So with this, let me end for the day, and further part let me take up in our future class.